Hello students, welcome to Akshar IIT Foundation. Myself Shivashankar. So I am going to teach physics now. In the last class, we are start today the continuation of last class. In the last class, we have discussed about the center of mass. Okay, center of mass and the position of the center of mass we have discussed. For the system of two particles, we have discussed, and then if n number of particles are displaced along the x-axis, what is the center of mass we have seen there. Now today will be continuation of that. We will see the continuation of that. That is, if the n number of particles are displaced along the y direction, then the center of mass of those particles. Okay. So it can be denoted by YCM, center of mass of system of n number of particles distributed along y-axis. Okay, this one will see that. So then all the particles, system of particles will be distributed like this. So here a particle will be there, and here. So like this, n number of particles are displaced there. Okay. So m1 mass of particle, m2 mass of particle, m3 mass of particle, so on up to here mn mass of particles are distributed along the y-axis. So this is the x-axis, and this will be the y-axis, along the y-axis, and they have a displacement of first particle is at a distance of y1, and this particle is at y2, and like up to there it is yn distance. The nth particle of the mass is displaced from the origin, this origin at a distance of yn. So then the center of mass of this particles which are distributed along the y-axis, we can write here the YCM. So YCM is equals to so mass of the first particle and displacement from the origin y1 plus mass of the particle and displacement of the second particle plus so on up to, we will get here mn into yn. So divided by we will get here sum of the masses of all the particles which are distributed along the y-axis. So this is the formula for the center of mass, which is all the particles which are distributed along the y-axis. Okay. So this is the center of mass along the y-axis. Now if the particles are distributed in the plane, means in the last class we have seen there these particles are distributed here, m1 particle and m2 particle like this up to so on, here mn particle are distributed along x-axis, that we have seen there. For that we have got the formula xem is equals to m1 x1 plus m2 x2 so on up to mn xn divided by sum of all the mass of the particles we have seen there. Okay. Nice. Now if the particles are distributed, it's completed now this one, the formula for the system of particles distributed along the y-axis. Now we will see there in the next topic, the particles are distributed in the plane. If the particles are distributed in the plane, the center of mass of system of particles in a plane in a plane. in a plane. Okay, we'll see this. Suppose consider this is a y-axis and this will be the x-axis. Y-axis and x-axis. Suppose here n number of particles. Let us consider this a mass m1 and here mass m2 and here this is a mass m3. So on up to like this n number of particles. Mn mass is distributed here. Mn mass. And from the origin, from here, from the origin, so it has the position vector. The distance is from here r1 distance. This particle has a distance r1. And the second particle, this is at a distance r2, and the third particle, this is at a distance r3. Then like so on up to here we have the distance up to rn. So like this all the particles will have the distance, like we can take here rn. So like this system of particles are distributed in the plane there. It is not along the x-axis, along the y-axis, it is in xy plane. So then how to find out the center of mass of these particles there, okay. So we can find out the center of mass of these particles like this. So the center of mass will be of this particle somewhere here, it will be there. So that will be have at a certain distance, that we can represent as RCM. Somewhere the center of mass will be here from the origin at a distance of here RCM into mass of all the particles. Mass of all the particles we can write here. Okay, that we can write. So m1 plus m2 plus m3, so on up to here we can write there mn into. So now mass of the movement of the each and every particles now, that is mass of the first particle and distance from the origin in r1. So plus m2 and r2 plus m3 r3. So plus so on up to here mn by rn. That is from the principle of momentum of masses. Then from this we can write RCM. RCM can be written as RCM is equals to m1 r1 plus m2 r2 plus so on up to here mn rn divided by m1 plus m2 plus m3 plus so on up to here mn, so on up to mn. Okay. This RCM, it can also be represented in vector form. This RCM can be represented in also in the vector form. So that vector form, vector notation RCM bar can be represented as, see here. So like this particle have the x coordinate, this is the x coordinate we have, and like here y coordinate we have y1. Like the second particle will have the x2 and y2. So now here we can write there center of mass of the particles along the x-axis I cap plus center of mass of the particles along the y-axis into j cap, we can write. So this is the center of mass of the particle which are in the plane in the vector notation, okay. Right. Understood, children? Center of mass of the system of particles in a plane. So here each and every particle, for each and every particle there is a x coordinate will be there and y coordinate will be there. So then center of mass of this system of this whole particle in the plane. So this is RCM can be written as m1 r1 plus m2 r2 plus m3 r3 so on up to mn rn divided by m1 plus m2 plus so on up to mn we can write here. So in the vector notation, these are the position vector r1, r2, r3 up to rn, they are the position vectors. Okay, then in the vector form, then the center of mass of the position vector of the particle which are in the plane. So that can be written as xcm, the center of mass of the particles along the x-axis and center of mass of the particles along the y-axis. We can write there I cap plus j cap. Okay. Now we will see there. So these are the particles. Up to here we have seen there the center of mass of the particle which are distributed in a plane or in a straight line. So then we will see there, if the continuous system of body, if a continuous body is displaced, like we can take a uniform rod, then where the center of mass will be there. Okay, if it is a uniform rod or if it is a non-uniform rod, then like extended object, for the extended object, where the position of the center of mass is there. So we know that if it is a regular shaped body, then the center of mass and the geometrical center of the body will be coincide there. So by the consideration of the origin, from the origin we can take the lengths of that, then we can find out. Otherwise, if it is a continuous body, then we will be go with the integration method. Okay, so that will be see there now. So next one, is it completed? Yes. Now next one we will see there. The position of center of continuous body. The position of center of mass of continuous bodies. Center of mass of continuous bodies. Like here we will take a uniform mass of a body. Like you can take the uniform rod of a body. Suppose here a uniform rod of mass m, it has a mass m and it has a length L. So length of this uniform rod is L and the mass of this rod is L there. Okay. Then how to find out the center of mass? See here. So we can consider, suppose the distance from here, L distance is there, no? We will consider from here, it is starting from, means we will consider here x is equal to 0 and so this is x is equals to L. That first end, the starting end of the rod will be at 0 and the other end of the rod, the ending point of the rod will be at a distance L. Okay. And in this we will consider a small part of the rod, we will consider a small part of the rod. So that is at a distance suppose dx. This dx part of the mass, this dx part of the this dx part will have certain mass now. So that dx part will have the mass, it is at a, let us consider that small mass which this dx part we have considered, it is a dm. Okay. So now here, so now we will start from this dx part of mass. If it is moved from here from 0 to L, 0 to L, whole length of the body, then now it is at a distance, so let us consider from this is at a distance x suppose. So from here to here it is at a distance, this dx part is at a distance x. Now this x value will be start from 0 to L, whole length of the body. Okay. So now we have to write here the center of mass. The center of mass of this system of body. So we can write here like this, the center of mass, like xem we can write here, xem into whole mass of the body. Whole mass of the body here we can write there, moment of whole mass of the body, here we have there capital M. The moment of center of mass can be written as capital M into distance of center of mass. Okay. That is equals to, we can write here, this is the dx part, it is at x0 and it may be at 1, x1, x2, x3 up to, so on up to here up to the L distance. Okay, that can be represented as with the integration, like we will write here, it is 0 to L, and here this is at a distance, mass of the body, x distance, it is from x distance, and this particle, which one we have considered here, the small part of the length, that is at a distance x from this origin, and the moment, here the mass of that small particle is dm, small particle we can write here dm, okay. So, it is nothing but what there, so x1 into moment, mass of that small particle at a distance x1 plus mass of this small particle at a distance x2, like that up to it will be this integration. Integration is nothing but summation of the small particles from the 0 to L. So, like that we can represent there, okay. So, now how to find out here dm. So, we will be considered there to find out the dm value. So, in the integration here the function variable is x now. So, there this has to be converted into the variable function there. So, differential function, differential distance. So, we can write here, for that we will use the linear mass density, So, that can be linear mass density is nothing but mass per unit length, here dm mass dx, and that is equals to whole mass of the length of rod is, we can write here capital M, and the length of the rod is L, So, mass per unit length. Now, we will from this we will get it there. So, dm is equals to capital M by capital L into dx, we can write there, okay, capital M divided by L into dx. So, now if you write here, so M into center of mass xem we can write here, that is equals to integral of 0 to L, x is starting from 0 to L, and here x into dm, what we got there, dm, from this we got there m by L into dx, we can write there, m by L into dx, okay. So, now m by L is a constant, it can be taken out from the integration. So, we will be right here, so m into xem, we can write here capital M by L, integration of, it can be written as here, we will write like this, integration here 0 to L, here m. So, m by L we can take common, we can take it out from the integration. So, here we will get there integration 0 to L, here x into dx will get there, x into dx. And in the integration we have learned that, so integral of, the formula we have seen there, integral of x power n dx, is nothing but, what is the formula, x power n plus 1 divided by n plus 1, okay, this is the formula. Now, plus c will come there, here we won't consider that c there, constant. So, here we can write now, here we can consider, okay, here we will consider there that point, apply that formula now. So, m by L, integral of 0 to L, So, here x power how much is there, 1, x power 1, if x power n, integral of x power n dx is nothing but x power n plus 1 divided by n plus 1. So, here what is the power, 1 is there. So, here we will get there this one, integration of this part. So, we will get there the formula x power 1 plus 1 divided by 1 plus 1. The limits, the integration has the limit, we will write here 0 to L, okay, 0 to L. So, next we have to simplify that. So, then, so note it down up to here, then we will go for the next page. Okay. Next one. So here we'll get there. So mass into center of mass of the particle, mass into center of mass of the particle, that is equals to, here we got what there. So m by L, we will get here x power 1 plus 1 will get, no? So that will be x square divided by 1 plus 1, 2. Here we have the limits 0 and L. Lower limit is 0 and upper limit is L. So now we have to substitute there m by L. So first we need to substitute in place of x, upper limit we have to substitute, then minus lower limit in place of x we should substitute there. So we will get here L square by 2 minus 0 square by L square by 2, 0 square by 2. So here we can add there L square by 2 minus, okay. So 0 by 2 will be 0 only, we will get here m by L into, so L square by 2 will be there, L square by 2. So here we will be get, this is a m into xem, and here also we will get m into xem, xem. So now from this we will get there xem is equals to, you can write here. So here what are the going to be cancelled there, L and L will be cancelled, and this mass and mass will be cancelled here, okay. Remaining is what here, xem, that is equals to, so L has remained here, L by 2 will be get there. So therefore we will be get here xem. So xem is equals to, xem it can be written as L by 2. So because it is the exactly at the middle of the rod there, because it is a uniform rod, so we got exactly at the geometrical center. So center of mass from the one end, from the 0, it is at L by 2. Even from that end also it will become L by 2 only, means if the object is a uniform rod, uniformly distributed mass of the object, then the center of mass will be coincide with the geometrical center. Okay. So for any object, like if it is a uniform or non-uniform object, so the formula for that center of mass of the object, so xem can be written as, our general formula will consider there. Suppose if it is distributed along x-axis, so we will write here integral of 0 to x, so x into dm divided by integral of 0 to x, 0 to n we can write here, 0 to n. So 0 to n we can write, and here also we can write there 0 to n, 0 to n, and here, so integral of m into integral of mass of m, whole mass. So here we can write here dm. General formula if the mass is distributed along the x-axis. So next we are going to see the center of mass of the some of the well-known rigid bodies. Suppose if it is a rectangular shape of a body, square or rectangular, so or it is a triangle. For the square and rectangle or the circle, the center of mass is coincide with the geometrical center. Suppose if it is a triangle, so it is will be at the centroid of a triangle there. So if you draw a medians from the each and every vertices, then all the intersection of the vertices is nothing but we know it is a centroid. So at the centroid, the center of mass will be there for the triangle. Suppose if it is a semicircular path, so it will be at a distance of suppose from the center of mass it is at a distance of 2r by pi. Suppose if it is a disc, then for that object it will be 4r by 3 pi. 4r by 3 pi will be there. Okay. So now we are going to see there, if the body has some of the body is added to the body, and some of the mass is added to the body, or some of the mass is removed from the body then. So in that case, the shifting of center of mass will be shifted. Okay, so then the shift in the center of mass. How can you find out the shift in the center of mass? Okay, that will be see there. Shift in center of mass. Shift in center of mass. Shift in center of mass. Suppose here a mass of the object is there, it has a certain mass m. So from that, certain amount of mass is removed. From this mass of the part is removed there. If it is not removed, from here, the center of mass may be considered, the center of mass will be here. This is the center of mass. The center of mass will be here there. From this certain mass, some amount of mass is removed there. This part of the mass is removed there. If this part of the mass is removed, then we will be get here. So it will be removed like this. So then we will get the part. So this is a part will be remain there. So remaining these will be yes. So this part will be there. Okay. Now the center of mass slightly shifted. The center of mass will be slightly shifted there. Then there is a small mass and there is a bigger mass. Slightly this center of mass will be shifted to this one. Let us consider it as shifted there. So how to find out that shift in the center of mass? Okay. Suppose this part of the mass has a m2, and this whole part of the mass is a m1. Consider there. Okay. So then the shift in the center of mass can be written as here general formula we can write here RCM. RCM is equals to so m1 x1. That part has shifted there, means minus the remaining part, remaining mass. This is the remaining mass is m1 and the removed part is m2. So m2 into x2. So divided by here m1 plus m2. m1 plus m2. The removed part is m1 plus m2 we can add there. Suppose certain area of the particle is removed there. So here we'll get there minus. This will be the minus. So m1 minus m2. m1 minus m2 will get there. So if area, the center of mass in terms of area, we can write this formula. So RCM is equals to area of the remaining mass into distance x1 minus removed area is a2 and x2 divided by a1 minus a2. a1 minus a2. So by using that we can find out the shift in the center of mass. Shift in the center of mass. Okay. So now we'll see there some of the problems. So practice sheet we'll see there. We'll see the practice sheet questions. First practice sheet. Practice sheet 1. Practice sheet. First practice sheet. See here in the first practice sheet, here we have the question, that is, among the following, correct one in the case of two particle system. Among the following, correct one in the case of two particle system there. So first option is given here, center of mass lie nearer to the lighter object. Center of mass always lies at the midpoint of a line joining the bodies, and center of mass lies nearer to the heavier body. Center of mass always lies outside of the system. Okay. So from this all, which one is correct there? We have discussed there, the center of mass of the body is nearer to the heavier body. Nearer to the heavier body. So option 3 is correct. Option 3 is correct there. Among the following, correct one of the following system, particle of the system there. That is the first question. So for the first question, so among the following, correct one in the case of the two particle system. In the case of two particle system, they are given there. So, first option is given, center of mass lies nearer to the object, lighter object, center of mass always at the midpoint of line joining the two particles, line joining the bodies, and the center of mass nearer to the heavier body. So, the third option is correct. Third option is correct one. So, fourth option, here first option is what is they given there, center of mass is nearer to the lighter object, center of mass are nearer to lighter body object, and second one is given, center of mass always line joining the bodies, It is not always, sometimes it may be there. If it is a regular shaped bodies, it may be happen there. So, now here the center of mass nearer to heavier body, center of mass nearer to heavier body, center of mass nearer to here heavier body, and next center of mass always lies outside of the system, center of mass lies always out of the system, So, this third one is correct there, it will be nearer to the heavier body, and second question is given there, center of mass of the earth moon system lies. So, first option is given, here. Second question is given, center of mass of the earth moon system lies, So, first option is given here, center of mass of earth moon system, center of mass of earth moon system lies. So, first option is given here, on the surface of the earth, and second option is given, on the surface of the moon, and third option is given, within the earth, and fourth one is given here, at the midpoint of the line joining their centers, at the midpoint of the line joining the centers, Okay. So, from this which one is we can correct there? So, we can see there here, like earth has a heavier mass than the moon, So, in a particular orbit about around the earth, the moon will be rotate, it will be rotated there. So, this is a heavier mass, then this is a moon there. Now, so it definitely it will be within it is not on the surface, it is not on the moon there, because mass of the earth is heavier than the moon. So, it will be lies within the earth. The center of mass may be here there, because of the mass of the earth is greater, in a particular orbit around the Earth, the moon will be revolved. So the center of mass, it will be lies within the Earth. So the third option is correct. The third option is correct. Okay. So next question we will see there. A ball is projected at certain angle with the horizontal, then, okay. Suppose I won't write here whole question, I will explain like this. Here the third question is given, a ball is projected with certain angle, like this, a ball is projected, then it will be fall here on the surface of the earth, If a ball is projected, so with certain angle, so it will be with certain velocity u, and here, so it will be made a certain angle theta. If it is projected certain angle, the path of a particle surface of the ball is parabola on the surface of the ball. The path of center of mass is a parabola. Okay. The path of center of mass is complex. The path of the center of mass straight line. So if a body is thrown, generally if a body is thrown into the air with certain angle with the horizontal, so it will be follow a parabolic path. It will be follow a parabolic path. Suppose if it is a rigid body, then the system of the rigid body, the particles of the rigid body, they may have the different motions, but the center of mass that body will be follow definitely a parabolic path there. The center of mass of the whole system of particles will be follow a parabolic path. So here the correct option is the path of center of mass is parabola. It is second answer. So correct answer is here from the given options. So option 2. Option 2 is correct one. Option 2 is correct one. So here, if a body is thrown, the rigid body maybe have the different system of particles. The different system of particles, they will be have their own path. So they also, it may be a parabola, but it is not regular parabola. But the center of mass will be follow exactly the regular parabola there. In the parabolic path, the path of the center of mass will be present there. So that is the correct answer. Okay. So next one, for regular shaped bodies, center of mass and center of gravity are coincident. Center of mass is nothing but what there? The mass, whole mass of a system of particles will be seems to be concentrated at one point. That point is called the center of mass. And the center of gravity is nothing but whole mass of the body seems to be concentrated at one point. So that point is called the center of gravity. For the regular shaped bodies, this center of mass and center of gravity will be coincide. Here options are given. First option, coincide with one another, does not coincide with one another. Second option. Third option is given, does not coincide with geometric center. Fourth option, coincides with geometric center. Okay. Coincides with geometric center. So they are asking, they are not asking about the geometric center. So we no need to consider here geometric center. We should consider here center of gravity. For the regular shaped bodies, center of mass and center of gravity will be coincide. Okay. For the fifth question, in the fifth question they given there, if three identical spheres, each of radius r, placed touching each other on a horizontal table, then the center of mass of the system is expected to be. Okay. So it is on the table, the three spheres are arranged like this, they are touching each other, one and another, touching each other then. So where the center of mass of the, and they are the identical, the mass of the spheres will be same and radius of the spheres will be same there. Then the center of mass is, means it is like a regular shaped body. The system of three identical spheres, then where the center of mass will be present there. Okay. Definitely it will be at the geometrical center of the body there. So where is the geometrical center of the body? So from the centers of each sphere, if you draw a line, if you join the each pair of the sphere, if you join the centers, then we will get a triangle there. Okay. So from the vertices of that center of the sphere, if you draw a median, so that median will be intersect at one point at that center of the median. So that will be intersect like this. Suppose if you draw a median like this, and from here a median like this, and from here a median like this, then we will get a center of mass here at the center. So here the center of mass will be present there. So center of mass will be present at this point. The center of mass will be present at this point there. This is a intersection of medians drawn from the vertices of the triangle which is line joining the two centers. Okay. So, this is the median. So, this is the center of mass. Center of mass will be. So, here the correct option is at the center of at the point of intersection of medians of a triangle formed by the centers of three spheres. So, this is a triangle formed by the centers of the three spheres as the vertex. So, here the answer we can write here, answer the correct option, option 3. Option 3 is the correct one. So, there the center of mass will be present. Okay. Yes, next sixth one. We will see the next one, sixth one, that is shift of center of mass generally occurs due to, shift of center of mass will be occurs due to. Here the option is given addition of matter, removal of matter, changing in shape and all of the above. So, we can consider here fourth option all of the above. So, if the mass is added to the body and mass is removed from the body, then the shape of the body has changed there. So, we know the center of mass is depend on the distribution of mass. So, if the distribution of mass will be changes, means shape will be changes, then the center of mass will be changed. So, here we can write the option, correct option for the sixth one. We can write for sixth one option, correct answer is option 4, all of the above. Option 4, all of these are correct there. Okay. Seventh one, center of mass is a. Seventh one is a center of mass is a point. Center of mass. Center of mass is a point. It is a point there. It is an imaginary point where the mass of the body seems to be concentrated, or we can say it is a balancing point where the at which point it can be balanced. If it is lifted or if it is lifted, generally it can be balanced. Okay, whole body can be lifted there. That is a balancing point there. So, it is a point there. Center of mass is a point. Center of mass is a point. So, here they given the options. Center of mass is a first option mass, second option point, third option scalar and vector, fourth option is vector is given. So, option 2, correct answer is for this option 2 we can write there. This is a correct. So, it is a point there. Center of mass is a point. Center of mass is a point.